Hello, algebra students. Today's section is 8.3, Simplify Rational Exponents. Please put your name and date. And we're going to start with a review of exponent rules. So do you remember the product rule? When we multiply powers, we add the exponents. And when we divide powers, we subtract the exponents. When we take a power to a power, we multiply the exponents. And when we have a, what do we call this? A term that is being raised to a power, the power gets distributed to both parts, so a to the x and b to the x. And when it's a division, okay, so I guess that was a product being raised to a power, and this is a quotient being raised to a power. The x gets distributed, so a to the x over b to the x. Anything raised to the 0 power is equal to 1. When you raise to the power of a negative, then we write that as 1 over the term raised to the positive. That's how you simplify negative exponents. And with this, we would distribute the negative, so it would be a to the negative n. Well, actually, let's do it a little bit different. Let's flip it and make the exponent positive, and then distribute the exponent so that we have b to the n over a to the n. And then we need to think about where we cannot have a 0. All right, so in the first case, we're not dividing by anything, so we don't need to worry about that. But for the second one, we're dividing by a, and so a cannot equal 0. Because if it were 0, any 0 raised to any power would be 0, and we would be dividing by 0. We also cannot have that in example 5, because we're dividing by b, so b cannot equal 0. And in 7, we end up dividing by a, so that cannot equal 0. And in example 8, in both versions, we're either dividing by a or we're dividing by b, so neither can equal 0. A nor b can equal 0 in the last example. All right. In this next case, we're looking at rational exponents, and we can have exponents that are fractions, and this is a bit new. So if you have a to the 1/2, that is really the same as the square root of a. So this is a new rule to remember. And if it's a to the 1 over n, then it's the nth root of a. So notice this denominator number is what you take the root of, okay? So same thing in 3, except we have a to the m over n, so the a to the m is in the radical, and then the n comes out here. These are the same, and so you could also write it in two different ways, and that's all this is showing it. Is the teacher I borrowed these notes from shows it in two ways. So let me see. His other way to show it is if you took a to the m power and then you did it to the 1 over n, then it would look like example 2, and so that's how we get to this same answer. All right. If it's to the nth power, then the answer, like if it's a to the n over n, then it's just a. If it's odd, or if n is odd. If n is odd. And it's a, the absolute value of a if n is even. But we're not going to worry too much about the absolute value bars, but that's just the rules. We're going to put them into practice. So using our exponent rules from before, a to the 1/2 times a to the 1/2 is a to the 1/2 squared, or it's 1/2 plus 1/2, which is just a to the first. And a to the first is just a. So thinking about this as radicals, the square root of a is the same as the square root, or the a to the 1/2. These are the same. And so the answer to this is the same. And these just cancel out. So we're left with just a. So a to the 1/2 is the square root of a. And we're just proving that. Okay, and so similarly, using the exponent rules for a to the third times a to the third times a to the third is a to the third, or I'm sorry, a to the 1/3, a to the 1/3, a to the 1/3 is equal to a to the 1/3 to the third, which is just a to the first, which is just a. All right. Then when we use it as radicals, the cube root of a is the same as a to the 1/3. And so if we multiply those all together, then these just cancel. The cube root and the cubed cancel, and we're left with just a to the first, which equals a. So a to the 1/n is the same as the nth root of a. For example, write each radical expression using exponent notation and each exponential expression using radical notation. So we're just going back and forth here. I'll do a couple and then I will let you do the other ones in your group. So the square root of 3 is the same as 3 to the 1/2. And let's go to C. This is xy in parentheses to the 1/4. And then I'm going to do E. That would be the square root of 5. In your groups, do B, D, and F. B, D, and F. Is this what you got for your answers? All right, evaluating each expression. So 16 to the 1/2 is the same as the square root of 16. And we know that the square root of 16 is 4. All right, let's look at C. Negative 8 to the 1/3 is the same as the cube root of negative 8. And we know that the cube root of negative 8 is negative 2. For E, we have the square root of negative 9, but that is not a real number. All right, do B, D, and F in your groups. go ahead and check your answers. Look at this next example. Write each radical expression using exponent notation. So we have the cube root of x squared. Let's change this to x squared to the 1/3. Now using our exponent rules, we can distribute the 1/3, and so it would be x to the 2/3. Okay, on this next one, let's simplify this 4th root of m to the 3rd. So 1 over m to the 3rd, but we are going to raise it to the 1/4 root. Then we can distribute this so that we get 1 over m to the 3/4. But since it's written like this, and we're going to change it to not a fraction, so you could also write it as moving this to the top makes the exponent negative. All right, for C, you have the 4th root being raised to the 5th power. So the 3 does not have the 5th power, but I could rewrite it as 3 to the 1/4 raised to the 5th power. Then I can distribute this so that we have 3 to the 5/4. So that's how we go from a radical expression to a exponential notation. And I'm going to highlight this answer just because I think the book might give it like that. But if you have this answer, that's fine as long as you know how to go to the negative version. When you're ready, turn the page. All right, now we're going to go backwards. So we had radicals to exponent notation. Now we're going to go from exponential to radical. 5 to the 2/3. I'm going to write that as 5 squared. And then I'm going to put my cube root. Or you could also write it as the cube root of 25. For B, it's to the negative 2/5. So the first thing I'm going to do is write it with a 1 in the numerator, and I'm going to make this positive 2/5. Now I have a squared, but I'm going to take the 5th root. Let's evaluate each expression. We have 9 to the 5th, or 9 to the 5/2, so that's 9 to the 5th, and I'm going to take the square root. So from here, I know I could also do what we did yesterday, or the day before, our last class, and change this to 9 to the 4th and 9 to the 1st. And take the square root. 9 to the 4th, well, that is going to come out. The square root of 9 to the 4th is 9 squared, and then we're left with just 9 inside. There are many ways we could do this. 9 squared is 81. The square root of 9 is 3, so this equals 81 times 3, which equals 243. Let me show you another way to do A. If you have the square root of 9 to the 5th, you could also write that as, you can just take the square root of 9, which is 3, and raise it to the 5th power. And 3 to the 5th is equal to 243. That doesn't work on example B, but let's take a look at example B. We have 8 squared, and we're taking the cube root. Well, actually it does, because the cube root of 8 is 2. So So if the cube root of 8 is 2, then we can just take this out as 2 squared, which equals 4. Does C work the same way? We have 27 squared and the cube root of that. The cube root of 27 is 3, so we can take that out as 3 squared, and that equals 9. So it did work. Go ahead and try, well, actually this one has a negative, so I think I should do this one with you. We're going to rewrite this as 1 over 4 to the 3 halves, which is the same as 1 over the square root of 4 to the third. Now you can just do 4 times 4 times 4 and take the square root. But the square root of 4 is 2, so then we can take 2 to the third, which is 8. But we have to have a 1 in the numerator, so that simplifies to 1/8. Okay, 81 to the negative 3/4. I'm going to write that as 1 over 81 to the third, and I'm going to take the 4th root. Can we take the 4th root of 81? Yes, it's 3. So this equals 1 over 3 to the third, which is equal to 1 over 27. For F, we are taking negative 8 to the negative 1, or to the negative 5/3. So negative 8, I'm going to write this in the bottom, to the positive 5/3 is the same as 1 over negative 8 to the 5th, and the cube root of that. The cube root of negative 8 is negative 2. So if I take the cube root of negative 8, I get negative 2, and then I'm going to raise that to the 5th power, which is going to equal -32. Let's try this for G. We have 1 over negative 8 to the positive 2/3. And at first I thought that this would become a not real number, but it's not. So I'm going to actually let you figure this one out in your groups, and we'll come back in a couple seconds, or maybe like a minute. In your groups, did you get 1/4? Let's go back to F, because I forgot that we need to have a 1 in the numerator here. So that should actually be negative 1 over 32. Okay. For this next example, we are multiplying. And so we're going to use, since we have the same base of 27, we're going to use our exponent rules, and we're going to add those fractions. So we have 27 to the 1/6 plus 1/2. We need a common denominator, so I'm going to change 1/2 to 3/6. 27 and 1/6 plus 3/6. That is going to be 27 to the 4/6, which reduces, sorry, that's written horribly. Let me just make it look nicer. 27 to the 4/6, which reduces to 27 to the 2/3. From here, we're going to do what we were doing before and simplify it further. So 27 squared and the cube root. The cube root of 27 is 3, so the answer is 3 squared, which is equal to 9. All right, I'll do the next one with you, and then I'll give you some time to work on C, D, and E. So we have 5 to the 3/4 minus 1/4, because that's the quotient rule. We subtract the exponents. And 3/4 minus 1/4 is 2/4, which is 1/2. And this can be written as the square root of 5, which cannot be simplified further. You try C, D, and E, and I will come by to help. Actually, I realized that these are not the same base. So they're different bases, so we're not going to add the exponents. But what we could do is write it like this: 3 to the 1/2, and 3 times 4 is 12. So we gotta be a little tricky here. And from here, we can put the 3 to the 1/2 together, like so. And this, if we add the exponents together, 1/2 plus 1/2 is to the 1st. And then we can rewrite 4 to the 1/2 as the square root of 4. And the square root of 4 is 2, so it's just going to be 3 times 2. So this one is equal to 6. I think you can do D. E is also doable. You'll just distribute this. But first, before you distribute it, flip them. Make this exponent a little bit smaller so it looks like an exponent. And then raise it to the positive 1/3. All right, so go ahead and do D and E. I think those ones are doable. And then we'll come back. Did you get 243 for D and 27/4 for E? Awesome. Let's try A and C together, and then I'll let you guys do B and D in your groups. For A, the 3 and the 3 cancel. We're not going to worry about absolute value bars, okay? And for C, 1/4 of 8 is 2. So this is going to be 1/4 of 8. If I multiply those, I get x squared, and 1/4 of 4 is just 1, so y. And that's it for that one. And we're not going to worry about the absolute values, okay? 1/3 being distributed, so to the 9 is going to give us x to the, actually I think I'm going to let you guys do that one. Figure that one out in your groups. And then we'll come back and go over B and D. Let's take these rules to another level. All right, we're multiplying powers, so we're going to add the exponents. 2/3 plus 4/3. That's going to give us x to the 6/3, which is just x squared. All right, for B, you would subtract the fractions. For C, you would distribute. So B is a little easier. Let's look at C. X to the 1/2
times 1/2 is written like this. And then y to the negative third times 1/2 is written like this. Simplifying that, we get just x to the 1/4. And then we have y to the negative 3/2. Continuing our rules, x to the 1/4 is the, let's see, they want us to write it with positive exponents. So we'll just write x to the 1/4 in the numerator, and we'll put y to the 3/2 in the denominator. It did not ask us to write it in radical form, so we'll just leave it like that. For d, since it's to the negative 1/2, I'm just going to flip it so that we're no longer dealing with a negative power. And then I will let you work in your groups to figure out the rest of D and to also figure out B. And I'll be coming around to help.
Check your answers. Did you get a to the 1/4 for B? And did you get y to the 1/6 over x for D? Awesome.